Hi dear class 10 students, I hope you all are studying well. So today we are going to start lesson number 4 of this chapter, Human Eye and the Colorful World. So guys, in this lecture, we are going to discuss atmospheric refraction like twinkling of stars, advanced sunrise and delayed sunset. And also we will cover scattering of light. Okay, now let us see twinkling of stars. So now my question is, what are stars and why do stars twinkle? So first of all, stars are point source of light. So stars pur hoise celestial objects that can produce their own light. And in simple language, we can say that the twinkling of a star is due to atmospheric refraction of starlight. So we will discuss this in detail. Now see what is light year. So light year is the distance travel by light in 1 year. So 1 year light to jiman to distance travel kore hetue hoise light year aru distance to hoise 6 trillion miles. Clear? Alright, now let us discuss why do stars twinkle. So stars are self-luminous and can be seen at night in the absence of sunlight, and they appear to be point sources because of their being at a very large distance from us. So basically, stars pur ami rati dekha pao, right? Our stars pur self-luminous. That means they can produce their own light. Our stars pur amar pora large distance ot thokar karone ami eta point source hisabe dekha pao. Clear? Now see, the apparent position of the star keeps changing a bit. This is because of the motion of atmospheric air and changing air density and temperature. So stars bilakor position to change hoi thake, and this is because of the motion of atmospheric air, changing air density and temperature. Okay, so because of this, the refractive index of air keeps changing continuously, and because of this change, the position and brightness of the star keep changing continuously, and the star appears to be twinkling. Etia soa Earth's atmosphere humor time starlight pure Earthkhon puar agote continuously refract kore. Okay? So itia ami janu je light to jetia eta medium or pora an eta medium travel kore, tetia it undergoes refraction, right? And hence its path changes. Now see here, the Earth's atmosphere has different layers. So the upper layers are rarer while the lower layers are denser. So as starlight enters the atmosphere, it passes through different mediums, as you can see here, and causing continuous refraction. So mainly air refractive index to change hoar karone atmospheric refraction to hoise. Am I clear? Etia soa atmosphere to starlight to normal dalor fale bend kori dise, right? Aru he karone staror apparent position to actual position otke slightly different, as you can see here. And also, the amount of starlight entering the eye flickers. That means, the star sometimes appears brighter and other time fainter. So this is the twinkling effect. I hope you all understood. Great. Now my next question is, why planets do not twinkle? Well, now see here, as I already mentioned earlier, the layer which is closest to the Earth is denser. Okay, so that layer is a denser medium, and the layer which is away from the Earth is rarer medium. Okay, now see, planet is nearer to the Earth compared to stars. So planets can be considered as collection of large number of point sources. Etia staror comparison otke planets pur ama Earthor bahut usort ase, aru he karone planets pur point sources hisabe appear nohoy, but appear as collection of point. So because of changes in atmospheric refractive index, the position as well as brightness of individual point source changes. So atmospheric refractive index or karone he individual point source or position aru brightness pur change hoy, and the average position and total average brightness remains unchanged, and the planets do not twinkle. And the different parts of these planets, they produce either brighter or dimmer effect. So the average position and total average brightness it remains unchanged. Hence the planets, they do not twinkle. I hope it is clear. So guys, tumalukor examot ei topic tur pra questions ahibo pare. Okay? So I hope your concept is clear now. Alright, now let us see another atmospheric refraction, that is advanced sunrise. So the sun is visible to us about 2 minutes before the actual sunrise. So advanced sunrise ot ki hoy swa? So actual sunrise ot ke sun to 2 minute honkale appear hoy. So guys, have you ever caught a glimpse of the rising sun just above the horizon? So normally ami sun to horizon or pra ulai aha dekho, right? Aru tar pisot sun rays bur refract hoi jay as they travel from more denser air to less denser air. And as a result, the sun appears to be in a position indicating that it has already risen. Etia tumaluke ei figure tut swa. So actual sunrise hole a sun to horizon to cross koribo lagibo. Okay? So jihetu sun rays bur Earth's atmosphere to strike kora loge loge refract hoi goise, he karne ami sunrise to actual sunrise otke 2 minutes earlier dekha pao. And as you can see here, this is the apparent position of the sun. Am I clear everyone? Okay, now next let us see delayed sunset. So the sun appears to set 2 minutes late. So delayed sunset ot ki hoy swa? Sun rays bur denser air or pra rarer air ole travel kore. Okay? Aru he karne sun rays bur refract hoy jay by atmospheric refraction. Aru refraction hoar karone sun to horizon or uporot appear hua nisna hoy. So delayed sunset ot sun to horizon ot 2 minute derike set hoy. And as you can see here, this is the sun's apparent position instead of its actual position. Okay guys, so this entire phenomenon, the advanced sunrise and delayed sunset, is caused by variations in the refractive index of the atmosphere. So I hope it is clear now. So next let us discuss scattering of light. So guys, what do you mean by scattering of light? So when a beam of light falls on a rough surface, it is turned back in different directions. Okay? And it is called scattering of light. Etia tumaluke yat soa, jetia kisuman parallel light rays ahi eta smooth aru plane surface ot incident hoy, tetia reflected rays buru parallel hoy, as you can see here. So this type of reflection is called a regular reflection. Aru regular reflection at angle of incidence is equal to angle of reflection. That means angle I is equal to angle R. So guys, tumaluke eta point monot rakhiba, reflection to jodi eta polished surface ot hoy, tetia he reflection tuk regular reflection boli koy. Okay? Aru regular reflection at angle of incidence kita equal hoy. That means angle I1 is equal to angle I2 and angle I2 is equal to angle I3. Similarly, angle of reflections kitao equal. As you can see here, R1 is equal to R2 and R2 is equal to R3. I hope it is clear now. Etia next swa, jetia kisuman parallel light rays ahi eta rough surface ot incident hoy, tetia he reflected rays bur scatter hoi jay. As you can see here, in different directions. So this type of reflection is called a irregular reflection. Aru a irregular reflection at angle of incidence is equal to angle of reflection. So at a rough surface ot jodi reflection to hoy, tetia he reflection to irregular reflection boli koy. Okay? So irregular reflection or khetrot tumaluke eta point monot rakhiba, yat angle of incidence kita equal nohoy. That means angle I1 is not equal to angle I2 and angle I2 is not equal to angle I3. Similarly, angle of reflections kitao equal nohoy. That means R1 is not equal to R2 and R2 is not equal to R3. Am I clear guys? Now see here, Earth has an irregular surface and that is why the light rays they scatter in different directions. So scattering is the process of absorption and then re-emission of light energy. So scattering to hoise at a process jetia light rays bur eta medium or pra an eta medium travel kore তেতিয়া লাইট ৰেজবোৰ এবজৰ্ব হয় ওকে আৰু তাৰ পিছত ৰি-এমিট হৈ যায় ইন ডিফাৰেণ্ট ডিৰেকশ্যনছ am I clear all right now let us see what are the factors affecting scattering of light so first factor to hoise wavelength etia soa a spectrum tut violet light or wavelength to hoise 4000 angstrom so a to hoise angstrom it is a unit of measurement for wavelength okay aru red light or wavelength to hoise 8000 angstrom so violet light is scattered nearly 16 times more than the red light etia soa second factor to hoise size of particle so the color of the scattered light also depends on the size of the particles now as you can see here for smaller particles scatter shorter wavelengths of light such as blue light okay and for larger particles scatter longer wavelengths of light such as red and orange light okay and for very large particles as you can see here the scattered light that appears white so this is how the size of the particles affect scattering of light so I hope you all understood alright now see due to a physical phenomenon the sky appears different colors so now let us discuss different colors of sky etia soa light rays bur jodi least distance travel kore বা কম ডিসটেন্স ট্ৰেভেল কৰে তেতিয়া স্ক্যাটাৰিং টু মিনিমাম হয় ওকে আৰু লাইট ৰেজবোৰ যদি লং ডিসটেন্স ট্ৰেভেল কৰে তেতিয়া স্ক্যাটাৰিং টু বেছি হয় এজ ইউ ক্যান সি হিয়াৰ আৰু লাইট ৰেজবোৰ যদি এটা লংগেষ্ট ডিসটেন্স ট্ৰেভেল কৰে তেতিয়া স্ক্যাটাৰিং টু ম্যাক্সিমাম হয় ওকে নাও এজ ইউ ক্যান সি হিয়াৰ red and orange color gets scattered least now as you can see here sunsets are red right so now my question is why sunsets are red so reason to hoise jetia sunlight to atmosphere ot humai tetia blue light to basically scatter kore more than the other colors and leaving a yellow orange hue to the transmitted light and this transmitted light makes the sunset appear reddish orange so I hope you understood this now see what is the color of sky in space so space ot sky color to hoise black right karon jehetu space ot atmosphere nai so he karone sunlight to scatter no hoy and thus the sky appears black in space because there is no atmosphere hence no scattering and thus there is no color am I clear everyone etia soa unlike space earth khon dark no hoy karon jehetu earth ot atmosphere ase so he karone sunlight to different direction at scatter kore okay and earth's atmosphere scatters shorter blue wavelengths of light more efficiently than other colors so this is why the sky appears blue I hope it is clear now okay guys so now let us discuss the last topic that is Tyndall effect so the phenomenon of scattering of light by colloidal particles is called a Tyndall effect so light to jetia eta medium or মাজেদি পাৰ হয় তেতিয়া হে medium to থকা particles বুৰে light to scatter কৰি দিয়ে okay and thus makes it visible so this effect is called Tyndall effect so we can demonstrate this Tyndall effect by performing this experiment so a experiment ot ami ki use korim soa so eta light source convex lens colloidal solution cardboard with hole aru ekhon screen so solution to prepare koribor karone ami first step ot panit sodium thiosulfate to dissolve korim aru next step ot concentrated sulfuric acid to add korim okay etia tumaloge experiment ut soa so first step ot ami eta strong source of white light jetia place korilu tetia he light rays bur a convex lens konor majedi par hoy a glass beaker to par hoise containing clear water then the hole in the cardboard and finally falls on the screen and on the screen we observed a white spot so as you can see in the figure a parallel beam of light is obtained etia next step ot solution to prepare kora pisot white light to jetia a solution to majedi par hoise tetia 2-3 minutes or pisot ami observe korilu je solution turns bluish, as you can see here, right? So here reason to hoise sulfur particles bure shorter wavelength or light to maximum extent oleke scatter kore. So from here we can conclude that violet, indigo blue gets scattered most, hence solution turns bluish. So violet aru indigo blue to basically scattered hoar karone solution to bluish hoi gol. I hope you all understood. And also we can conclude that orange and red are scattered least, hence reddish orange spot is observed on the screen. So orange aru red to least scattered hoar karone reddish orange spot to ami screen khonot observe korilu. So this experiment help us to understand why the sky appears blue and why the sun appears red during sunrise or sunset. Okay students, so we are almost done with this chapter. So I hope your every concept is clear, and in case if you have any doubt you can comment. And in the coming last lecture we will solve some numericals. So stay tuned. Thank you.